Tube A has both ends open while B has one end closed. Otherwise, the two tubes are identical. What is the ratio of the fundamental frequency of the tubes A and B? So we have two tubes A and B, okay? So we have this tube A, both ends are open, okay? And we have tube B. For tube B, okay, one end is closed and another end is open. Now, from question, tube A and B are identical, okay? They are identical except that A has both ends open while B has one end closed. So we need to note this, okay? So therefore, okay, the length of tube A equals length of tube B. So we have this. Clear? This is to be noted. So let the length of tube A be capital L and the length of tube B is capital L, okay? So this equals L. So we are denoting length of both tube by the symbol capital L. Now, we are asked to find the ratio of the fundamental frequency. So in order to find fundamental frequency, so we use this relation, okay? Speed V equals F times lambda. Okay, so we are going to use this. Clear? Now, for tube A, okay, we have this V equals F naught A times lambda, okay, where F naught A, this is fundamental frequency for tube A. Now, at fundamental mode, okay, so I'm writing at fundamental mode, we have this, okay. We always have anti-node at the open end and we have node, okay, between two antinodes. So we get this, okay. So we have node between two antinodes. So at fundamental mode, this distance, okay, that is antinode, node, antinode. So this distance is lambda by 2. So at fundamental mode, we have lambda by 2 equals L, that is length of the tube. So we have this. Therefore, we write, okay, lambda equals 2 times the length of the tube. So we have this. Clear? So fundamental frequency for tube A equals V by lambda, okay, and this V is the velocity, okay. So we have this, or speed. I'm writing in magnitude right now. So we have V equals, sorry, V by lambda is twice L. Therefore, we have fundamental frequency for tube A equals V, that is speed, divided by twice L. Let us call it equation 1. Clear? So we are using this finally to get this result. So as I said earlier, V is the speed, F is the frequency, and lambda is the wavelength. Okay, so we have this. Now for tube B, okay, we have V equals F naught B times lambda. Okay, so we have this, and F naught B, okay, this is fundamental frequency for tube B. Okay, so we have this. Now at fundamental mode, okay, we have this. We have antinode at the open end, and we have node at the close end. So we get this, okay. And this distance, that is antinode node, okay. Distance between antinode and node is lambda by 4. So we have this. So at fundamental mode for tube B having one end closed, okay, we have lambda by 4 equals L, that is length of the tube B. Therefore, we can write lambda equals 4 times the length of the tube. Therefore, we can write F naught B equals V, that is speed, by wavelength, and we know wavelength is this, okay. Therefore, we can write V by lambda is 4L. Therefore, we have this result, okay. Let's call it equation 2. Now we are asked to find the ratio of fundamental frequency of tube A and B. So fundamental frequency is the lowest, okay, frequency. So we must note this also, okay. It is the lowest frequency. So this is the lowest frequency for tube A, and this is the lowest frequency for tube B. Now let us divide 1 by 2. So we get this. V by twice L divided by V by 4L, we get V by twice L, 4L by V. So this cancels out. This cancels out. So we have 2, okay. Finally, so we can write in this way, okay. F naught A by F naught B equals 2 by 1. So we have this. So this is the ratio of the fundamental frequency of the tubes A and B.